Students, next concept I am going to explain thermochemistry. Thermochemistry it mainly explain chemical reactions are associated with the transfer of energy. Now, if the amount of energy is transferred can be measured, how much energy transferred in a chemical reaction we can measure. That's the what type of reaction also we can identify. The thermodynamic, what type of, for us see, we know already the exothermic reaction, endothermic reaction. If the reaction is completed, it is what type of reaction? Energy is absorbed or energy is released. Now, for see one example, I am writing. It is a 4Al plus 3O2 to form Al2O3. That is the 2 moles. In this case, it is a exothermic reaction. It is a exothermic reaction. In this case, the transfer of heat to surroundings. How much energy means? That is delta H. The heat is minus 1676 kilojoule per mole. This much amount of energy is transferred from the system to surroundings. Thus, in this process, based on the chemical reaction, this is a chemical reaction. In this chemical reaction, how much energy is transferred, we can calculate. And also it is a what type of reaction? It is a exothermic reaction. It is also exothermic. This type of reaction. For example, one more example if you see, is example 1. Now example 2. Now in this case, that is a N2 plus O2. They form 2NO. In this case, it is a endothermic process. In this one, the energy is absorbed surroundings from the systems. How much energy? That means the delta H is, these are the standard values, 90.4 kilojoule per mole. This much amount is absorbed from the system to surroundings. These types of relations explained by the thermodynamic. Now, what are the standards of thermochemistry? Now, in this one, the pure substance of liquid or solid phase, the state is pure, that became pure solids or liquid state, and the gaseous standard state is the gas at the partial pressure of 1 atmosphere pressure mixed with the other gases. And also the substance of solution, the standard states refers the 1 molar concentration. Now in this one we can learn that one more concept, that is heat of reaction. That nothing but heat of reaction means we can say the heat change taking place in a reaction is called as heat of reaction. For example, see the reaction A plus B, it is a chemical reaction to change C plus D. That is now heat is Q amount is in this reaction. Now the heat of reaction is delta H is equal the H enthalpy of product minus enthalpy of reactants. In this case, enthalpy of product is, we can write as enthalpy of product. They are enthalpy of C plus enthalpy of D. Enthalpy of C plus and enthalpy of D. These are the products minus. Now enthalpy of reactant, that is enthalpy of A plus enthalpy of B. These are the, now it is a product, enthalpy of product This is the enthalpy of reactants. Enthalpy of reactants. Now in this case, if enthalpy of product is equal to enthalpy of reactions, means heat of product is equal to heat of reactant, then the heat is change in the heat become 0. It's nothing but they are equilibrium. Now if heat of product or enthalpy of product is greater than enthalpy of reactants, then change in enthalpy is positive quantity. The reaction said to be a endothermic reaction. Now here heat of product is greater than heat of reactants, then the change in the enthalpy become positive quantity, then it is a reaction is a endothermic process. Now one more, if heat of product is less than heat of reactants, then change in the heat is become negative. The process is exothermic. These are exothermic thermos. Now generally enthalpy of every element in any state is equal to 0. Any state is equal to 0. Some factors also affect on heat of reactions, and also the reaction takes place at constant pressure or constant volume. The reaction takes place at constant pressure and constant volume. In this case, the formula we have, that is enthalpy, change in the enthalpy is equal to change in internal energy plus number of, that is a gas in RT. In this case, delta H is a heat of reaction at constant pressure. It is at constant pressure and it is at constant volume. Now it is the difference between number of moles of product minus number of moles of reactants. Number of moles of product minus number of moles of reactants. Now if at constant pressure, at constant pressure, the equation is become delta change in H2 is equal to delta H1 plus C delta Cp at T2 minus T1. We can write at constant volume, it become delta E2 is equal to delta E1 plus delta Cv, that is a T2 minus T1. These are the formulas. Also we can use some other calculation. This is the main formulas, the heat of reactions.